couple of reminders as we start these videos. Students are to have their study guides with them and ready to write down the notes that are presented in this. We will not be taking time to pause the videos. You've got the pause key on your keyboard, and you can stop the video, write down, or work out the example, and we'll just continue on the recording just a little bit of time. Each time we start a new section, you're going to see that we have the goal. In this particular section is called Numbers and Operations. And the goal or the learning target for this is to define prime and composite numbers. And the last thing we need to do is to work on prime factorization. Let's get right started with that, with these definitions. And the first thing that we're going to be defining here is a blank number. It's a whole number greater than 1 with exactly two numbers as factors, the number 1 and the number itself. So by definition, that is a prime number. The second area we're going to be working on defining is a blank number, is a whole number greater than 1 that has more than 2 factors. That, by definition, is a composite number. The third area we're going to be working on is right here. When a number is expressed as a product of factors that are all prime, the expression is called prime factorization. Let's practice a few of these. Let's try the number 71. We're trying to identify what the number 71 is. Number 71 is divisible by 2. No, it's not. It's divisible by 3. No, it's not. We don't have to check anymore on the even numbers, because if it was divisible by any even numbers, it would have been divisible by 2. How about 5? Will 5 go into that? We can just divide by 5. As we try 7, safe in saying that the number 71 is prime. Let's look at number 57. Is 57 divisible by 2? No, it's not. So let's try 3. Let's actually go through the work to do 3 here. 3 into 57. 3 going to 57 one time. 3 going there into 5 one time. 27, 3 going to 27, 19 times. So, if you look at the number 57, 3 times 19 is 57, and we can say that, first of all, it is a composite number, and that the factorization would be 3 times 19. If you look at the number 50, try that. First of all, we can see it's divisible by quite a few things, but let's start with the number 5. So 50 is divisible by 5, and we'll get 10. How about 10? Is 10 divisible by anything? Sure it is. 10 can be divided by 5 again. 2. How about the 2s and the 5s? Are they divisible by anything? No, they're not. So the prime factorization, first of all, is a composite number. And the prime factorization for 50 is 2 times 5 times 5. I'm going to have you pause the video at this point and work on number 47. And then come back and we'll work on 47 here. 47, we tried the number 47, we tried the number, try to divide it by 2, no, it's not divisible by 2. By 3, how about 7, no, 9, 11, as we go through all of those, I think with a little bit of work, you're going to find that it is a prime number. Let's work on 45. So just a minute, we're going to pause the video, but you work on 45 and then come back and listen to the video. The number 45 is divisible by quite a few things. 45 can be divided by 5. 5 will go in there 9 times. 9 can be divided by 3. 3. So 45 is a composite number, and its factorization would be 3 times 3 times screen. Examples of factor trees, right? Let's work on the number 60, write a factorization for the number 60, and we can start and say, all right, 60 can be factored into 6 and 10. 6 can be factored into 2 and 3, and of course 10 can be factored into 2 and 5. So the factorization for 60 becomes 2 times 2 times 3 times 5. Please work on the number 50 on your own, and then come back and we'll check the video out to see if we agree. Looking at the number 50. The prime factorization of 50 can be 5 and 10, and then the 10 can be factored into 2 and 5. So the prime factorization for 50 is 2 times 5 times 5. Again, try 48 on your own, and then come back. The number 48 can be factored like this. 48, 2 and 24. 24 can be broken down into 2 and 12. 12, of course, can be broken down into 2 and 6. And 6 can be broken down into 2 and 3. So when we look at that and we write out prime factorization, it is 2 times 2 times 2 times 2. That's 1, 2, 3, 4 2s times 3. All right? And we've got one last one to work on. Let's work on 45. Again, pause the video, practice yourself, and then come back. 45 can be factored into 5 and 9, and the 9, of course, can be factored into 9 can be factored into 3 and 3. So the prime factorization for 45 is 3 times 3 times 5.